Okay, so I have started recording. That's fine. Now let us start. Move on to the next slide. So this is what we are going to talk is AWS and object storage. So there are different type of storage. We have object and block storage. So block storage is something we are going to discuss in the computer EC2. Here we will talk about an object storage, and then we are going to talk about content delivery network and something called as the S3, and we are going to talk about Glacier and CloudFront as well. So apart from this, we are going to discuss about a few storage gateways as well, and we are going to discuss about a few more topics like Snowball or Snowball Edge. So what is this? We refer as Amazon Snowball, Amazon Storage Gateways. So these are a few things we are going to talk about. So there is something Amazon Elastic File System that also we will discuss, but that we would be certainly discussing while we are going to do the compute thing. So the very first thing, so what is this Amazon S3? So it is a simple storage service. So the very first vision of Amazon infrastructure, which was released on the year 2003, basically the whole idea was to create web services to maintain the storage infrastructure. So that is where it is basically mentioned as a simple storage service. So that is where 3S comes into picture. So that is where the name comes as Amazon S3. So it is going to be a storage for the internet. So we can use Amazon S3 to store and retrieve any amount of data at any time from anywhere on the web. You can accomplish these tasks using the AWS Management Console, which is simple and intuitive web interface. So this is nothing but the same web interface from where we had done the identity access user manager. So from that same thing only we are going to discuss or operate this S3. So that is basically called as a AWS Management Console. Now, before we run into this AWS, these things, about the a year when about 2006 or maybe between 2006 and 2008, so there was a guy basically, for example, if you talk about ourselves also, we use our pen drives to carry our files. Now, what if there is a situation that you are not able to use your pen drive, you are not allowed to use your pen drive, and you wanted to certainly access your files? So that is where one person basically who was the founder of Dropbox, basically what he has done is he has uploaded all of his files from his USB drive to something called as an Amazon S3, which is called as an object-based storage. So what is object-based storage? We will talk later. We'll talk on this slide. So before that, let me complete this story of this Dropbox. So basically, he uploaded all of the files into S3. So now, as of today, so that guy is a millionaire, a multimillionaire, and he's holding his 90% of data all into Amazon S3 because of it is durability or simplicity you can talk about, and the cost wise it is that much effective. Rather than maintaining his own data center or storage, he has been uploading his 90% of data to Amazon S3. So why 90%? So there is another 10%, basically those are called as a metadata or indexes about the data. So that is something he's maintaining it locally, but yes, the actual data is basically hosted in Dropbox. So that is why the Dropbox was one of the very biggest partner that has been done with Amazon to upload his 90% of infrastructure. And after that, in 2006, Amazon itself has moved its whole operations of Amazon into this Amazon cloud. So after that, we got hundreds of and thousands of examples. If you look at into the success stories and latest news and events and updates of the Amazon, there are thousands of companies and bigger infrastructures. For example, Airbnb in local, we have examples of Redbus. There are many companies that has been moved onto this Amazon S3 as a primary storage. So what is this Amazon S3 so crazy about it that so many people are moving in? So this is what we call as an object-based storage, and it is intentionally built with a minimal features. So it doesn't have hundreds of features to operate with it, but whatever the features and it is having it, we are going to discuss about this in this lecture. So basically it is more simple, it doesn't have many complicated features, so and it is very robust in nature, so that is why everybody is adapting it. And the data that is being picked up by this Amazon S3 is spread across multiple devices and facilities. Of course, we have discussed about the regions and availability zones. So an availability zone is nothing but referred as a data center, and definitely it is having multiple devices across multiple facilities also. So there is certainly, they say that there was unlimited storage. So what does it mean by unlimited storage? Yeah, as we know, like in one availability zone, there is roughly about 80,000 servers, and there are roughly about a lakh of storage servers that they are maintaining. So if any of the availability zone that is reaching to, let's say, 65, 60 or 70% of utilization, so they would be piling up the data center with more and more storage. So that is how they are managing it, making it to ultimate unlimited storage availability. Now, it is an object or file size that can range from 0 to 5 terabytes. So, when we call it an object based storage, it has to be a simple file. Object, so what is an object? We will discuss in more detail in the subsequent slides. But for now, what we think is the object is, if you can refer as a small Word document, or you can talk about a small text file. So, whose size can start from 0 bytes to 5 terabytes. So that is what a file size can be up to a maximum limit. That is what you can upload it to something called an Amazon S3. Now these files are stored in buckets. A bucket can simply be referenced as a folder or container. So I would not call it as a folder. I would rather say it is a container. So a bucket is a simple container, and it is a universal namespace. So name must be unique globally. You're registering your email address in a Gmail. You are searching for a name. For example, your name is Amit Rath, and you are searching for amit.rath at gmail.com. It certainly says that, no, sorry, boss, this is occupied. Certainly you can use amit.rath12345 at gmail.com. So that is called as a universal namespace. So likewise, Amazon S3 is a universal namespace. So for example, if I want to create a folder called as a Datanza training, and I'm giving that name, if that name is taken by somebody else, certainly I cannot use it. So I have to choose a universal namespace, and it must be unique globally. So the reason behind making this unique globally, we will come to understand when we will go ahead and try to use it. So the reason behind making it unique, so that from any region or across any part of the world, you can access the same bucket. It is not limited, or it is not isolated within your laptop. For example, if you talk about a folder, you create ABC folder in your laptop, you create it on every laptop. So they are isolated systems. So wherein we talk about on Amazon S3 object-based storage, the reason or the intention behind this is not to make it isolated. The reason behind this is to make it more simple and global. So that is why it is a universal namespace. So on the last line, what you can see here is there is a URL https://s3. So S3 says it is an S3 object storage US-east-1 that says that yes, this is the region. This is the region where basically this S3 storage is allocated, and following to this Amazon AWS.com/Datanza. So Datanza is nothing but going to be my bucket name. So this Datanza bucket is an S3 object storage that is basically located in a US East 1 region basically. So that is where I'm going to access my objects. So it is as simple as simple. You don't need to host a domain of your own. You don't need to have a website. You just go ahead and type this URL, and certainly you can have an access to your files. So that is how simple as it is. So these are few basics of Amazon sorry, S3. Now we will discuss something more on the S3 concepts, and then slowly we will move ahead with making use of an Amazon S3. Sorry. Okay, a bucket. So as I discussed, a bucket is a container for the objects that is stored in Amazon S3. So every object is contained in a bucket. So every object, what do we mean by object? We discussed that it can be certainly a Word document, can be a video file, can be a PHP file, it can be a text file as well. But yes, this object has certain more criteria to this, how this object is basically maintained. So these objects are nothing but the fundamental entities that is being stored in the Amazon S3. So what do you mean by this fundamental entity? So this object is basically, as we discussed, it is going to be a simple object file like a Word file or music file or a video file. But this object, how it is basically tracked, named, or identified within a bucket is basically, it is done by something called as a key. A key is nothing but a name, and there is a version ID. So what is this key and version ID, and how this is basically consisting of? So what is this object name or this identifier is basically consisting of? So the key, when we talk about the key, it is nothing but it's just a unique identifier. I'm saying it is an ABC dot txt is the file name. So that is basically the name of the object. So that is the key basically. And the second thing is going to be the value. So it is simply is the data made up of sequences of bytes. So in abc.txt, you might be having 100 lines, might be having 1,000 lines. So basically, it does a hashing kind of algorithm. It does mathematical functions kind of stuff, and basically, it finally arrives to a numeric value. So that is nothing but sequences of bytes. Maybe your file is of, let's say, 100 bytes, so it may be picking up that as a value. So it is going to be simply a unique, a numeric identifier it is picking up, and uh, and that is basically picked up on the basis of the sequence of the bytes. So the bytes is nothing but the file that you have uploaded. From his size, the sequence, whatever it comes, so that is a value. Now the key, now there is a value pair, now there is something called as a version ID. And on top of that, we have something called as a metadata. So these are the four things that is basically, combining together, and they call it as an object. So call it as an object means I'm gonna refer it as a unique identifier for the object. So object is nothing but it is your Word file only. It is nothing but your music file only. But yes, that object is identified by combining the name of the object, by generating a number from the size of the file, that is a value, and there is something called as a version ID we will talk about, and there is some metadata. So this metadata is something we can supply. For example, we can say the type of the file, we can say it is a document file, we can say it is a finance department file, we can say it is English text file. So this metadata is basically, we are trying to say that what kind of data it is going to use, so or what kind of data it is holding actually. So we can specify this metadata, and using which we can basically, this object name is basically found out. Now coming to the versions, so versioning enable buckets enable you to recover objects from accidental deletion or overwrite. So what is this versioning enabled buckets? So it looks little Korean to me, but so when we call about versioning enabled buckets, so it is nothing but it is a bucket. Yeah, that is where we are going to object our files. So files is nothing but we are referencing here as an objects. They are going to upload to a bucket. That is okay. We understand what is a bucket. It contains an object. It contains a file. So what is versioning? Now let us talk about a Windows Word document. So we all work in the corporate industries. I don't know how frequently we are doing a documentation, but let us talk about one document you created for first time. Let us say that you're saying you're doing a health check of your database or your infrastructure. So that document name is going to be health check, and I'm going to add something called as a version 1.0. So I'm going to name my file as a health check version 1.0. Now, after 1 or 2 days, I'm doing some changes to the document. Some people just save the file after changing it, and the best way, basically, some people what they do is they save the file in a different name. They call it as a health check version 2. After 2 days, they may again make some changes to that file, and they save it as a health check version 3.0. So there is two advantages to it. So overall, on the span of 10 days, I have changed the file 3 times. So I don't know on which day what changes I have done. I don't recognize it at all. It is a big document. So the size has been also increased day by day. So whenever I'm making some changes, the size is also getting increased. Now accidentally what happened, somebody deleted my latest file called as version 3.0. So the first way what we do is we look into our recycle bin and we see if that file is available, then we restore it. If that is not available, then you have LCheck version 2.0. You can get that file and do your further or latest changes. So that is how you can at least save up to your 90 to 100% of your data from being lost. Okay, but Think about the person who's not maintaining such kind of versions and who's just simply creating a file called as a health check dot document or dot txt, and every time he's making a change and he's saving it as a health check dot txt. That's all. So one day if the file is deleted and unfortunately if not found in recycle bin, it is completely lost because there is no older versions of the file is available. So this is what I was trying to explain in a theoretical manner. So a versioning is nothing but the different copies. So whenever you make a change or you delete or you edit a document, there are different versions are created automatically. So that is basically, you can specify. There is an option we are going to see in the lab that you can tell one bucket whether to enable versioning or not. So this is a very important feature of the buckets. This can certainly comes in the exams as well. So this is something we are going to use it in practicals today. So these are few basic concepts we discuss about what is Amazon S3 and what is Amazon S3. Few concepts, buckets, objects. Objects is consisting of key values, value pairs, or version ID and metadata. So now you can understand how does this version ID can come from. So you will have different versions whenever there is a change happens to your file. Okay, so buckets can be in one of the three states. So unversioned, that is the default state. So as I said, in a practical, we are going to see, we are going to enable versioning on a bucket. If you don't enable it, so that is the default one. It is unversioned. You lost the file, you lost the object, it is gone, you cannot recover it. There are no previous versions are available. So that is the default behavior. And you have to change it to versioning enabled. So once you enable the versioning, you cannot go back to the default. So certainly you can say versioning suspended. So you can either enable the versioning and after enabled, you can go ahead and suspend it or re-enable it. So that is what you can do with that bucket versioning. Okay. Now coming back to this Amazon S3. So we call it as a very simple and robust storage, but yes, there are a few concepts that we must need to understand to understand how do they actually work in a real time. So in order to understand, we understood like bucket is basically a container that holds your objects. That is pretty fine. There are thousands of objects that is being kept. So when we keep on storing our objects, there would be time when we need to delete or overwrite or edit a particular document. So how is that going to work? So that is nothing but how is your data consistency is basically maintained. And this is certainly there are a couple of questions, one or two questions that do come in the exams as well. And of course, it is very important to understand. So this is a concept again. So this is not something we have to do it on a daily basis, but yes, we must need to understand this concept. So this is called as a read after write consistency for puts of new objects in your S3 bucket. Okay. So what does it mean? Puts is nothing but it is a HTTP method. So get, put. Okay. So these are the few HTTP methods. These are the methods used by XML or HTML language. So if you might have ever done a little bit of HTML or XML, so you can understand put means putting a request and get means querying something from a particular website or particular web service. So puts is basically putting something onto the server. So sorry. So putting something onto your S3 bucket using the Amazon Web Console. So it is going to be a read after write consistency. So for example, let us talk about an example. Now there is a file. So that basically you have done editing and you are putting that file back into the bucket. So if you see, we have enabled versioning, let us imagine. So we have a version 1 file. Now you did some changes. You made a version 2 file. So the word example we discussed, there we were creating it manually, V1, V2, different version name you are giving. But here you are not doing that. So here the number of different versions I'm talking is a logical version. So the file name is going to be abc.txt that is there in the S3 bucket. We have already uploaded it. Now in that abc.txt, there were 10 lines of text. Now you open the file, you downloaded the file. you did added up another 10 lines. Now abc.txt file is 20 lines. Now you're putting it back. So you're putting it back means it is going to do a writing. So when it is going to write, it is going to change that old file which was having 10 lines. It is going to keep that as an old version file, and he's going to upload another file that is the latest one, and which is having 20 lines, but the name is going to be same abc.txt. So while this put request is happening, if there is a person, a second person, and if he's trying to read that file, then he is going to get the first read consistence copy. So he's going to get the first file having 10 lines because your put request is still in progress. So as long as your request has been not completely uploaded, okay, so it will not give you the latest file with 20 lines. So having said that, all the request, whether it is a put or get request, it is all atomic. For example, in Windows, you are doing a copy of the file, you double click the file, you're not able to open it. It is going to say that you cannot open it. So this is not an atomic behavior. So, but here you have an atomic behavior is possible, and read gets a priority and after write. So read, so whichever is a consistency model, you are going to get a read copy of that. So that is nothing but we call it as a read after write consistency. So eventually consistence for replace, delete, writes, overwrites for puts and deletes. So eventual consistency is nothing but the same behavior that we have discussed in this example. So basically it does a read first and then do the write. Okay. Okay, now this can take some time to propagate. So that is what we have discussed. Okay. And this is atomic. When there is a read request, you get eventually consistent read or consistent read. So there is a typo. So basically you get an eventually consistent read copy of your data. So this can take some time to propagate. Okay, that is okay. Fine. So this is basically, it does the read and it will give you the previous copy or the previous version if the latest version is still under writing. Okay. So what we discussed so far, we discussed about the Amazon S3, what it is. It is object-based storage, first thing. In object-based storage, we don't talk about blocks and all that. We talk about just an object. The object is nothing but consisting of your key, value pairs, person ID, metadata, and they contain in a bucket, and bucket is can be enabled, version enabled we can do with the bucket. By default it is not done. Okay, and we see that in the concept how the read consistency is done. So there is a read after write consistency is basically taken care, and it is atomic in nature. So when you put a request, you will get a consistency copy. So either your file is corrupted, you won't get it. Otherwise, you will always get a consistency read copy. It has to be either a previous version or it has to be either a current version. Okay, so whatever we discussed about the concepts, there is few more things as we are going to discuss is about the storage classes. Okay, now here we comes to the little out of the concept, and this is very important. Please keep it in your mind. The practicals also we are going to have a look at it. So this is where basically we jump into the types of storage you can say. So I would not eventually say it is a type of storage. The perfect name is of course it is written and explained, that is the storage classes. Okay, so the storage classes are majorly divided into two categories. So this Amazon S3 storage is basically divided into two categories. One is called as one storage class is for frequently accessed objects, and another storage class is for infrequently accessed objects. So there are two types of files that basically some files you access very frequently and there are some files that you access it very infrequently. So the storage classes has been defined on basis of these two or basis like how frequently your objects are being accessed. So let us first talk about the storage classes for frequently accessed objects. So this is suitable for performance sensitive use cases. This is suitable for performance sensitive. What is performance sensitive? So you need an immediate response time. You want to read a particular file, you don't want to wait for a big longer time. Okay. You remember if you have ever used a floppy, you try to open a file, it does take some time. Then CD, that becomes more faster. Then DVD, now we got USBs, now we got hard disk drives, now we got hybrid storage, now we got SSD. So you can see there is a performance sensitivity between SSD and HDD and USB. A similar kind of performance sensitivity is also required for your business, which requires that in milliseconds of access time. I want to I click on it, I get it. That's how fast it is. So and it has to be very frequently accessed data. So these are basically the storage classes defined for them, where the performance is important and the data is accessed very frequently. Now in that storage class, we have two types of further storage classes. Those are called as a standard, and another one is called as a reduced redundancy. So what is that? Now the standard storage class is basically the default storage class. Okay, and when we talk about the storage classes, they are applicable to an object. So what is an object? It is nothing but your file, and these objects basically go into a bucket. Inside a bucket, you store all your objects. Okay, inside a bucket also you can create more folders. Every folders inside that you can keep objects. So it's just like a simple Windows folder kind of stuff. So when you talk about these objects, so these storage classes are applicable to them. So what does it mean? If you, for example, I'm uploading a file, my resume.docx. So I'm uploading this document file. So Amazon Web Console is going to ask me, where do you want to keep your file? In which storage class do you want to keep your file? Is it going to be a standard storage class? Is it going to be a reduced redundancy? Or it is going to be two other types? So there are four types of storage classes, and majorly there are two classes. So one is for frequently accessed objects, another two is for infrequently. Now we are discussing about the frequently accessed object. So the default storage class is standard. So let's say I don't want to choose. So by default, your object will be in your standard storage class. So that is fine. We will discuss about it in more detail. We are going to have a lab on this as well. Now, reduced redundancy, what does it mean? The reduced redundancy storage class is designed for non-critical, reproducible data that can be stored with less redundancy than the standard storage class. So looking at this, it says very clearly that reduced redundancy is basically for those kind of data that is non-critical, for example, and those data can be reproducible. So reproducible in the sense, it basically doesn't gives your data guarantee on a reduced redundancy. Okay, so what does it mean, less redundancy? For example, think about thumbnails and pictures. So pictures in mobile, or if you talk about your website or in any applications or videos, you see there are two types of things. One is basically your thumbnail. A thumbnail is a smaller icon kind of representation to your larger picture. So in mobile, when you list your pictures, you see very small pictures. So certainly you can call them as a thumbnail pictures. So when you click on that thumbnail picture, actually it goes to storage of your mobile and it picks up the bigger image. So that is the actual data, that is the actual picture. So this is basically there is two parts. One is the actual picture, one is the thumbnail. So if you lost the thumbnails, it doesn't matter because thumbnails can be recreated anytime from your picture. So if that is the case, basically, Amazon recommends that you use reduced redundancy for such kind of, non-critical or thumbnail kind of pictures, so which can be even gets lost also. So there is though some recommendation has been given by Amazon. This is that we recommend that you do not use the storage class. The standard storage class is more cost effective. So I mean, cost-wise, there is not much difference coming into standard and reduced redundancy, though they have created two separate ways to store your data, upload your objects basically. But they still recommend to go for a standard one. It doesn't matter as much. Okay. Now there is a second for durability. The RRS objects have an average annual expected loss of 0.01% objects. So there is chances that this reduced redundancy storage is going to have some loss from the data. And if an object is lost in this storage class, when requests are made to that object, Amazon S3 returns a 405 error. So it is going to say that, sorry boss, that picture is not available if you are storing it in a reduced redundancy. So basically there is a 0.1% of loss is expected in reduced redundancy. And in standard basically storage class, no, there is no loss basically. So this is the two types of storage classes and are meant for frequently accessed objects. And on the next slide, we are going to talk about the second storage class for infrequently accessed objects. So there is two types of data we discuss. One is a frequently, one is a infrequently accessed objects. So when you talk about storage classes for infrequently accessed, again there are two more basically sub classes we have. One is called as a standard underscore IA, and another one is called as a one zone underscore IA storage classes. So these storage classes are designed for long-lived and infrequently accessed data. Long-lived and infrequently accessed data. Oh, how does it matter? Okay, we will discuss an example how do they basically fall into different categories. So standard underscore IA and one zone underscore IA objects are available for milliseconds access, similar to standard storage class. So what is the difference between the previous standard reduced redundancy and this one? So the difference between both of them, this is infrequently accessed objects. This is meant for or designed for infrequently accessed objects. So there is a typo error. Please excuse me for that. It says frequently accessed. So I have to remove this frequently. So okay, so I'm sorry. Okay, so this is what I have just corrected. Okay, this is infrequently accessed objects. So standard IA stands for infrequently access. So we have standard IA and one zone IA. So whether it is infrequent access objects, whether it is frequent objects, we have a standard storage class that we discussed in the first slide. This is the standard storage class. It is also used for performance sensitive, so that requires milliseconds access time. So which can be accessed very faster. Okay. Similar way, this infrequently accessed objects in these two storage classes can also be accessed very faster. Store data in a minimum of 3 availability zones. So standard underscore IA is basically it is stored in the 3 different availability zones. We discussed that in one region we got 3 availability zones. So if you put your object into the standard underscore IA storage class, okay, then they are going to replicate it across all the 3 availability zones. So one zone is gone, you will have your data available in 2 remaining zones. 2 zones are lost geographically, they are blasted off or flooded off, but still you have 1 copy is available in the 3rd availability zone. So S3 standard IA offers the high durability, high throughput, and low latency, ideal for long-term storage and backups, and as a data store for disaster recovery. This is something is very important. So what is the use case they are recommending? For example, let us say that you're operating from Asia Pacific Mumbai region. Okay, the region for close to us is Mumbai, and that is where I'm hosting my website. I got an S3 storage attached to it. I got at least thousands of files that is getting uploaded, and those thousands of files are basically uploaded to a standard storage class. And my availability zone is in Bombay, Asia Pacific. Now what I can do is basically I can take a copy of my data from Mumbai region and I can copy it over to London region. Why do I want to do so? So I will copy it basically to a London region, and while copying it, I will say that standard IA. So the copy which I'm doing to London, that ideally I'm not going to access it. So that data is going to be infrequently accessed, but the data that is going to be frequently accessed in Mumbai. So Mumbai region, I'm going to keep it in standard class, and the London region I'm going to keep it in a standard underscore IA class. So that is where it is basically used for long-term storage, backups, data store for disaster recovery. So there is a very high durability of the objects across this multiple SJ. Is availability zones. As I said, out of three, if two is gone, still it is available. Designed for 99.9% availability over a given year. Use for your primary or only copy of data that can't be recreated. So it cannot be recreated. So you cannot bear a data loss. So you always use standard underscore IA. Now, why it says so, if you talk about standard one zone underscore IA, so this is a much cheaper option. Okay, pricing wise, this is going to be offer you a much discount on this or much lesser price. So data will be lost in the event of a availability zone destruction. Oh, so what does it mean? Unlike your standard underscore IA and your standard storage class is stored in minimum of three availability zones, but when you call your data to be one zone underscore IA, they are stored only in a single availability zone. So if I'm keeping my file in one zone underscore IA, then if that availability zone is lost, so my data is gone. So there is no backup and nothing. So basically there is a small risk factor. The same data is basically not multiplied to multiple availability zones. So again, this is also having a high durability, but yes, the availability time or the high availability is basically reduced by 0.5%. Okay, so when to use it? So use it if you can recreate the data if the availability zone fails, or for object replicas when setting across region replications. So basically, it also says like you keep only those kind of data in this zone. Basically, wherein if you lost your data, you can certainly recreate it. Okay, so there is a second disaster copy you are trying to create. You're copying your database or VM image or something, you are copying it, and you have a primary copy somewhere available in your standard storage class. And there is a second copy, certainly you can put it in one zone underscore IA. In case that is lost, also, you can again go ahead and copy your primary copy one. So that is where basically this standard one zone underscore IA. So basically when we talk about the storage classes, they are meant for two type of access objects. One is a frequently and one is infrequently. So in infrequent access objects, we have standard and one zone IA. So in one zone, basically the storage, S3 storage or your bucket or your objects is basically maintained in a single availability zone. When you talk about standard underscore IA, your copies are maintained in the three availability zones. Okay, so we're going to see a comparison about this, and we are going to talk more about this. But before we go ahead and move on to this, we are going to talk about the Glacier storage class. Excuse me. Okay, now Glacier storage class. So unlike we have a storage classes, we have a similar thing. It's called as an Amazon Glacier. So Amazon S3 and Amazon Glacier. This is also a storage class, though it is a little different type of storage class, and it is meant for only a specific type of storage, and that is for your archiving of your data. So what is it, archiving of your data? So Glacier is a secure, durable, again extremely low cost. So this is the very important part, extremely low cost storage service for data archiving. Okay, so it has got a high durability. It is spanning across multiple availability zone. Extreme low cost design is ideal for long-term archive. What does that mean, long-term archive? There is a financial organization called NBFC or a banking organization or an insurance company who deals with the public finance. They need to store the data for, let us say, for 15 years as per the government norms and regulations. But being an insurance company IT head, I know that I'm not going to use 5 years older data. So, but I'm keeping 15 years older data in my database. My storage is consuming to hold 15 years of data, which is ideally not required. So 5 years older data persons has been disconnected the relationship with banks. Why do I keep those storages? The storage is a very expensive part. So what we can do is basically, let us talk about those data which is older than 5 years. I can have an option. I will move it to some storage class called as a glacier storage class, where it is very cheaper, of course, extremely low cost, and it doesn't. Though it is also spanning across multiple availability zones. I don't need to have a fear of losing my data. And second thing is that if there is a data requirement that comes up that there is a report needed for about 8 years back who had some fun and all that, so certainly I can ask them to hold for a couple of days, and I'm just gonna restore a few files or objects from that glacier. So it will take some hours, up to 3 to 5 hours. Unlike your other storage classes, standard IA, RRS, and one zone IA, they had a millisecond performance. Huh? They had a millisecond. You wanted an object, you have to get it in milliseconds. It has to respond. But in Glacier, it is not there. So Glacier is kind of offline storage, though it is not offline. So you move your data to Glacier, and when you need, you have to restore it back from the Glacier. Okay, so it will take some time depending on your sizes and files and all that. So it will take up to 3 to 5 hours. But yes, your older legacy data is now, instead of sitting idle on your peak or main storage, now at least it is moved to a lower cost option. So that is where Amazon Glacier now comes into picture. Now on this last line, you can see, if you look at here the mouse pointer, the Amazon Glacier now offers expedited retrievals, typically in 1 to 5 minutes. Latest update. So what does it mean by saying? So just now I saw latest update. Now Amazon Glacier, the response time which I was saying 3 to 5 hours is basically getting reduced in minutes. So even though you are archiving your data in extremely low cost storage, which was earlier taking 3 to 5 hours, now as per the latest update since a week of time, now it can be retrieved within 1 to 5 minutes. So more on that we can see later. So basically it says there are a few notes we need to say. So you cannot specify Glacier as the storage class at the time you create an object. Oh, that is important. I'm creating a new document file. I can put it in a standard storage class. I can put it in a standard IA storage class. I can put it in a one zone IA storage class, but I cannot go ahead and put it directly in Glacier. So what does it mean by Glacier? So basically, what is the idea behind coming to the Glacier? If you have data that is sitting idle and it is very, very less infrequently accessed, not even frequently, it is very, very less expected, there are less expectancy of getting accessed, then it is recommended that you move your files to Glacier. So what does it mean? If an object creation time is older than certain days, for example, there is a new client has come to my company. Okay, as long as he's active, as long as he's coming daily, as long as he's logging into my website, so that user stays active. If the user doesn't log me to my website, let's say for about 30 days or 60 days, or maybe let's say for about a year of time, okay, so that user is deactivated, so there is no meaning for me to keep his data. So certainly I cannot delete it, but yes, I have to keep it, right? So I can specify a certain amount of time after which a particular object can go to Glacier. So that is basically called as a life cycle policy. So we are going to discuss and have a hands-on lab wherein we can talk about, sorry. So yeah, so basically it has to go through a life cycle management. So there is a life cycle you define, let's say for 1 year, 2 year, 3 year, 5 years. If object creation date is getting older, yes, you move it to Glacier. So you must first restore the Glacier object before you can access them. As said, the performance is not going to be in milliseconds, so you must need to restore, restore that object. Okay, and then you can go ahead and access that object. So standard RRS, standard IA, and one zone IA, these objects are available for anytime access. So this is one of the major difference. Consider, keep it in your mind. This can come in the exams as well. The glacier is not meant for frequently or infrequently accessed data. Okay, it is meant for keeping your data that has been idle for a long period of time. So you use some lifecycle management policies to age out your data to Glacier. Okay, so Glacier is basically, the name also says the same thing. So Glacier is nothing but the ice is basically piled up in Everest for a longer period of time when they become glacier. So that is how. So your data is becoming idle, so they become a glacier. You should move it to the glacier storage class. So let us have a comparison between all of the storage classes. Okay. So here it is. So here it says the storage class is a standard IA, one zone IA, glacier. You can see the durability it is designed for is 99, 99, 99. Only RRS is having less percentage. And we see that RRS is meant only for the data which can be reconstructed. So that is why the durability is quite less. Okay, so any other considerations for standard storage class? Nothing. Okay, so but yes, for standard IA, there is a retrieval fees for the standard IA object. The class is more suitable for infrequently accessed data. Okay, so one zone underscore IA not resilient to the loss of the availability zone. So we should not be resilient to the loss of the availability zone. So one zone is gone, so the data is gone from that. Though it doesn't happen that quite frequently, your availability zones are getting crashed out. It doesn't happen so frequently, but yes, still there is a chances. So that is why the availability is designed for one zone underscore IA is 99.5%. Okay, now for Glacier, again availability is designed for 99.99% after you restore objects. So basically it is not available in fly like other three classes. It is kept in the Glacier. If you want to access your file, you can restore it. And once you restore it, so definitely it is available for 99.9%. So these objects, Glacier objects, are not available for real-time access. You must first restore archived objects before you can access them. So that's what about the Glacier objects. So this is a standard comparison between this things. There is still another more comparisons if you talk about the available SLA. So Amazon gives a standard service level agreement. If you are storing your buckets in S3 standard IA or one zone IA, you will have 99.9% availability. So service level agreement. It falls below that, then Amazon will fails to maintain that service level agreement and is ready to pay the penalties. So that certainly will not happen. That is why they are guaranteeing that amount of SLA. So if you see, there is no SLS is applicable to Glacier. Look at the availability zones. In S3 standard, it is greater than equals to 3. S3 standard, IA greater than equals to 3. One zone is only 1, you can see. But Glacier is again distributed across multiple availability zones. Okay, so minimum storage duration charge. So that is what for 30 days. So after 30 days, basically it is recommended that you move your data from standard IA to one zone IA, or you can decide after 90 days you can move to Glacier. So minimum 90 days, your object old has to be done, or old has to be minimum 90 days, then it can move to Glacier. So how the fields is basically retrieved. So every GB that you are retrieving. Okay, so every GB gigabytes that you're retrieving, you're basically being charged for that. Okay, so first byte latency, the first byte latency is nothing but, so when you're trying to access your object, so how fast it can respond. So Amazon Glacier takes about minutes or hours that we have seen. Others are going to take about milliseconds. So what type of storage? All are they? They are all object storage. Okay, so they all fall under lifecycle transitions. We can create policies for them. So the storage classes were quite important in order to understand them. Okay, now this is something that's very important. Okay, Let me see. I still don't have a pen today with me. So this is something I wanted to draw and explain you, but let me try to do it using my mouse. Hopefully I can make you able to understand this. What is this? Amazon S3 transfer acceleration. Okay. So this is another service. Okay. This enables fast, easy, and secure transfers of files over long distances between your client and an S3 bucket. Okay. So again, I'm reading S3 transfer acceleration enables fast, easy, secure transfers of files over a long distance between your client and an S3 bucket. Transfer acceleration takes advantage of Amazon CloudFront's globally distributed edge locations. So we have discussed that CloudFront basically it uses something called as edge locations to keep a cached copy of your data so that your data can be easily be retrieved by that nearby the region users. Okay, so it uses that same edge locations. It uses the CloudFront. As the data arrives at an edge location, it is routed to Amazon S3 over an optimized network path. And when using transfer acceleration, additional data transfer charges would apply. So this is going to an additional billing. But what it is this? Basically, let us talk about a use case. For example, you talk about scriptd.com, you talk about slideshare.com. My S3 bucket, okay, let us say I'm creating a site called as a slideshare.com, or I'm creating a dice.com. In slideshare.com, people are uploading the slides to my website. There is a YouTube. People are uploading their videos from different regions to my site. But if let us say it is MyTube, okay, let's say MyTube is a video publishing channel like YouTube, and where it is hosted, let us say MyTube is hosted in Bombay. Okay, I have created a my site, which is a video publishing site, mytube.com, and let us say it is hosted in Bombay. So it is hosted in Amazon. I created an Amazon S3 storage bucket, and I'm asking people to upload your slides to me. I'm asking people to upload your videos to mytube.com, and my S3 region is in Bombay. So my S3 region is in Bombay. So that means my bucket is in Bombay availability zone. So in Bombay, I've got 2 or 3 availability zone. My bucket is physically located into Bombay region. Now people are uploading from different parts of the world. For example, there is a person who uploads the data from Japan. So it uses the backbone of internet. So how this internet backbone is created, that internet, it doesn't come straight away from Japan to Bombay. It passes through many routers, many channels, many countries, many seas, basically. And from Japan to Bombay, it might be coming across 5 different countries, or maybe 2, 3 different countries. The file is transporting and coming to me. So there are 5 different channels. There are multiple channels using which a file is basically transformed from. You can say the file is transferred from Japan to Bombay. Okay, so Japan to Bombay, it is coming from multiple channels. Now, a similar way it is coming from US, Korea, South Africa, Australia. So when they're uploading, the upload latency is very high, so it takes a lot of time. So instead of I do so, what I can do is I can go ahead to Amazon.com. I can go to Amazon CloudFront. Something we will discuss more about CloudFront, how we are going to create and do all this stuff. We are going to create some distributions and something. So basically, I'm going to say that we are going to create a few edge locations we are going to use. Let's say America, Japan, and Australia, and London. These 4 edge locations I want to use. So when the person from Japan is uploading the file to mytube.com, so that file will first go to Tokyo edge location. And from Tokyo edge location, that file will directly be copied to a edge location near to me, that can be either Chennai or Bombay. So Bombay is near to me, so it will be uploaded to Bombay edge location. So the file is now copied through Amazon channel using edge location to edge location. It doesn't have to travel through so many multiple different channels. So thus making my files arrive very quickly. So basically they make use of these endpoints basically. So using these endpoints, they upload the file to the endpoint. So basically when the user from Japan is uploading 1 GB of file, if that file is getting directly uploaded to Bombay and it is coming through the internet the backbone, it will take at least, let's say for 10 gigs file, it is going to take 30 minutes. But the same user, if he's gonna upload it to the edge location, instead of 30 minutes, that file is going to upload in 10 minutes, though it is a 10 gigabits file. So thus enhancing your business more and more. Now this way people will be more attracted to upload your videos to your site because you're using your edge locations that is making me upload my things faster. So it doesn't matter how fast my internet is, basically, it matters much how big the latency is. So traveling from Japan to Bombay through 10 different channels, the latency becomes very higher. Now in Japan, sitting on a city or streets and uploading it to Tokyo edge location, it is very quick because the latency is less. So that is how basically a transfer acceleration works out. So well, you can see that the example, why use Amazon S3 transfer acceleration? You might want to use transfer acceleration on a bucket for various regions, for various reasons. So you have customers that upload a centralized bucket from all over the world, as we discussed, Japan and Australia, different places. You transfer gigabytes to terabytes of data on a regular basis across continents. As I discussed, mycube.com is very popular. For example, a lot of videos are coming from across the world. So you are underutilizing the available bandwidth over the internet when uploading to Amazon S3. So whether I can use the edge networks basically to get it uploaded to my region that is sitting in Bombay. So this is called as a transfer acceleration that basically helps you to pick up your files rather than picking it from an internet multiple linear or longer latency channel. It can certainly pick up your files from the edge locations and put it basically to your Amazon S3 bucket. So basically it is a medium by which you can get your files in faster means to your Amazon S3 storage. Okay, so this is concept. So this was a theoretical concept, but yes, certainly we are going to talk about the cloud front, how we are going to work and how this is locations. Okay. Okay. So any questions so far, guys? Very soon we are going to have a discuss on the